Okay, so let's go quickly what we could do today, and then we'll have to finish up Saturday night, the rest. So, um, uh, where did I put it? Um, I put it on, let's see, here. Oh, still here. Okay, Google Drive, and it's under, don't worry, I'll move your thing to the
Yeah,
right
thanks.
folder. Yeah, and, uh, uh,
Yeah,
where is it? A final review? It should be, here it is. Okay, so far we just got this document here. Okay. Um, oh, and generally, maybe I'll just make a quick document. How do you do that in this? Is there a way to create a new document? Just right click, Google Docs. Uh, is there something I could do? I don't know what it just did, but okay. If I save it, it's going to save here in this folder. I don't know. Let me just do it in Word. So basically, what's going to be on the test, so on the final, so this is going to be a very short list. Um, basically, um, most, okay, okay, so most questions, uh, um, everything within the final is, what's the word? It's comprehensive, or what's it means like for everything in the course. What? Cumulative, but mostly from cumulative, but mostly I would say 90% is from um, is from is from after chapter three. Okay, so stuff we did after chapter three. Um, uh, um, then, I'm not guaranteeing because I didn't actually check it. But most of the questions are from after chapter three. Also, what's going to be on this is the diagrams, right? The UML diagrams. Uh, and that's pretty much that's really it, right? So it's mostly stuff we did with after chapter three, and then the UML diagrams, and then what were the chapters we did? We did um, uh, I forgot, but we go through folders, so I'll just save this over here. So right now it's not that actually complicated. Um, oh, and then also review um, the presentations after the midterm. Okay. Where's my document? Okay, number three is, this is for the last 6 points. Uh, review uh, presentations given after the midterm. I'm not sure which ones they are, but I basically did the later ones. Okay. I asked like three true and false questions. Okay. So that's going to be it. So that's basically it. I'll add it to it as we offhand. I was going to write this before, but I forgot to. But that's basically me. But it's basically just go through the folders and see what's in every folder, right? So save this. What's oh wait, that's not the right folder. Uh, uh, where is it? Where's my folder? Doesn't remember it. Um, Here we are. What's on the okay, and I'll just upload this. And then while I'm doing that, actually, maybe let's just go through the um, folders and figure out which are the ones that were after the midterm. So over here, and then I think it's, does anybody know offhand when the midterm was? What's after, let's see, midterm review, if it's in order. Oh, I could sort it by order? Uh, um, I think, what? Say again? After class 13? Okay, 13 was, uh, yeah, oh, so after that? Great, thank you so much. How'd you figure that out so fast? What?
I have the dates and the classes.
Okay, yeah, see, right. So from class 14 and on. So let's find that document. Um, uh, where we at? Oh, okay, so um, okay, so after from class 14. Thank you so much. Okay, okay, okay. Um, okay, so let's go through the sample, final. Okay. Um, okay, so CDCI, right? What does that stand for? I'm sorry? Yeah, very good. Right. So I say configuration development, that's wrong. Has everybody heard what he said? Continuous development, continuous integration, right? Which is basically a pipeline, right? So one is false, three is false. I just made up some things. Nothing to do with waterfall, right? It has to do with checking in code. Should occur once a month. There's nothing to do with Scrum. So this would be the answer, that it makes frequent deliveries of software. Also, um, this is actually this I'm going to get out of here because I don't know what that means. I used to. This is a very old test I wrote. Okay, so I don't write tests the same way anymore. Uh, I mean, but this is a good idea though. A non-functional requirement is an unnecessary requirement? No, that's wrong, right? It's what is a non-functional?
Like performance authority.
It's something that it usually affects many functional requirements. So it's actually more important than functional because it affects a lot of things like what did you say? What was the example you gave?
Okay.
Yeah,
Like it's implied because
I'm sorry?
for security or performance.
Yeah, something very important for the whole program, right? Like performance. Is it requirement? No, that's not a non, three is wrong. And usually has a smaller scope, which is just opposite. It has a larger scope, is not related to customer success, and that's just made up. I usually run out of ideas by number five. Okay. Uh, um, I try to be tricky, but okay. So what type of diagram is this? Remember what this is called? What is this called? Oh, yeah, I know the diagrams, right? This is called the use case diagrams. Okay. And there's four parts to this, right? This is not a use case table. Use case table is different, right? This is a very high level and the use case table is low level. It tells you, line by line, what should happen. First, this happens, something goes wrong, we do this, right? The use case table is a couple pages. This is a small diagram showing like a very bird's eye view of the whole project. So the project itself is listed by the activities it provides. So for example, our shopping system has 4 activities, right? You could view items, make purchase, complete checkout, and then that's all it does, right? These 4 activities is what our program does. And over here, these guys, what are they called? The stick figures? Actors, right? And what do they do? Right, they interact, close, they interact with the activities, right? So for example, this guy interacts with 3, this one only interacts with 1, and this guy only, PayPal interacts with 1, and the customer interacts with 3. So no one, I don't think, interacts with all of them, right? Doesn't look like it. So, okay, so credit payment service must log in. Where is credit? No, nothing to do with that. First of all, it doesn't mean they have to. So this is definitely wrong. Customer can only perform 2 activities. Nope. Customer could do 3. PayPal is a service, not an actor. Well, it could be a service but it doesn't have to be even if it's a service, in this case, it's an actor because it's outside the program, right? Anything that interacts with the program is an actor. And this is true, complete checkout. Where is that? Oh, complete checkout interacts with 4 actors, right? Right, 1, 2, 3, 4. So that one is the most popular one. Okay? And this is a context diagram. This is not a context diagram. It's a use case diagram, right? Okay? Good to go? Okay, next. This is, what type of diagram is this, by the way?
Sequential diagram?
I'm sorry? Right, sequence diagram, right? And then what are these guys called with the funny lines? What? Exactly, right. These are lifelines. And what what uh what happens when you go from the top to the bottom of the diagram? Right. It's getting right. Time is going on. What are these arrows? You're good. Yeah. What are these arrows? What?
Is that like a sequence?
It's not really, they're actually called messages, right? Well,
I mean, like send.
right. So when you send a message, it's a solid arrow, and then this is a return message so basically these objects we start at the top where this guy gets a message, he sends it to this guy, and then it returns over here, and then this one sends a message to this object, and that one returns back there, right? So that's the flow of the program, okay? Obviously, there could be, if something goes wrong, then but we're not going to make it that complicated, right? So this is a very high level or low level diagram. Very low, right? It's telling you actually how they talk to each other, right? Right? So it's very, 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 very low level, right? It's telling you just how basically 3 objects are going to deal with each other, right? Oh, the only thing I left out is what is this bar over here?
The action.
The what?
It's like the action.
The activation, right? It tells you how long that's why I think why they're called lifelines. I'm not sure where the name lifeline comes from, but I think it's because it's telling you how long it's alive. I don't know. Maybe someone else knows why it's called a lifeline. but I think that's why, because this bar tells me it tells me how long it's alive. So in this case, in this over here, the object that's most active would be this one over here, right? The register office. Okay. Um, I don't think I have to go through the questions. Should I go through the questions? Oh, how many lifelines are there? Three. Yeah, that would be the answer. Okay. I thought it was, oh, there's another question there. Which object is activated the most? And the answer, that's a bad question. It's whatever, but it's this one over here. It should be which one has the most activation time. Uh, is active the longest? Right? And the answer would be I'm doing this online, so you get updates right away. I'm doing this in Google, so. Um, right, so the answer would be the register office, right? Okay. Should I write the answer or? Yeah, it's better to register office and then just underline it. Oh, what? Oh, no, underline is control U. Right. Okay, whatever. Um, what did I just do? I just clicked something I didn't, I didn't want to click. Anyhow, let's make this bigger. And then we said how many lifelines there are. We said three, right? Okay. Um, forget this. We didn't get into Java really. Forget that one. Um, okay, wait a second. Let me zoom out a little bit. Over here. Eight. The following pattern is typically used for undoing user actions. Okay, so we didn't do that. I'm sorry. Yeah, actually we did. Yeah. Well, yeah, the answer really is command pattern, but we didn't do it. So I'm going to delete that. So, but we could use the memento. Um, is used, not typically. Right. So we could do the memento because it also does it, right? Because it saves this for I'll just change the question. Fountain pen is used for restoring a document contents, right? Okay, that makes sense, right? So we didn't do the command pattern, so the answer would be the memento, right? Because it keeps a snapshot and then we could use it to restore. Any other ones we didn't do? Yeah, everything else we did. So basically, you should just know the patterns, remember them a little bit. So the observer pattern is the basic idea is you add observers without modifying existing code. Strategy pattern is what? What's the idea behind the strategy? What?
Like the Delta.
Yeah, but what's the basic idea? We want to encapsulate.
Basically, behaviors.
Yeah, right, exactly. Yeah, whenever your strategy, think behavior. That's how, basically restoring the behavior of an object in the class, which we then pass in, right? So that's the whole idea. A lot of these things are very similar. So the strategy pattern is we're stuff that change is outside our, in other words, we try to keep our code just to have the stuff that does not change, and the stuff that changes, we put into a separate object and we pass it in, right? That's like a common theme throughout design patterns. Okay, good? Okay, I know I'm speaking fast. I'm just trying to cover more stuff. Okay, are we good? Factory pattern controls what gets created. Iterator allows it gives like a generic way to go through objects, right? I'm sorry, go through a list. Um, a state pattern basically stores stuff in different states. I'm sorry. It basically the object moves. It's sort of like the state diagram where the object it goes through different. You could in other words you have the same methods, but you just change the state and then the methods do different things, right? Like with the car, when it's in reverse and you push the pedal, it does one thing. When it's in drive and you push the pedal, it does something else. When it's in park and you push the pedal, right? So they have the same method, but depending on the state, you get different results, right? So the Okay. And then decorator pattern is basically we could chain different objects together so that you don't have to keep track of all the different objects. Just call one object, you call one method, and then all the objects that are chained to it are going to get called. Like we had for a lot of people did like pizza, stuff like that. So you could have different toppings, and then but you don't have to know how many toppings there are. You just say get price, and it'll go through all the different toppings and return the price of all of them, right? So, or the other example I gave was a logger, right? You could have a logger that does logs to 20 different places, right? To log to the screen, to internet, but or send emails, but you don't care. All you know is you call one method log, and then automatically they'll call everybody else in the chain, right? You don't have to like have a list of objects because each object knows about the other object, right? They have a pointer, a reference to other objects, right? So when you call one, you're calling all of them. Okay, that's the nice part about it, right? You don't have to be aware of what's going on. Memento, we said, takes a picture. Builder protects the object from bad values. Um, and a singleton is a safe way of having a global variable, and it's only one, protects a global variable, and make sure there there is only one object created. Okay, that's why it's called singleton, right? So it's a little bit of encapsulation that protects the global variable. It's a little bit of how to use a global variable safely, and also it's a way of only one object be created, right? Ensuring that. Um, okay, this you don't have to know. Sorry about that. I mean, it's not bad, but we didn't really, it's not really necessary. Um, And why is this eight and that one eight? I don't know. The following is not part of software development lifecycle. So we said daily meeting is part of what?
It is.
Scrum. Targeting rule is I made up. Analyze current system. That would be for reuse, right? We analyze uh, I don't know, I forgot which one it is, but it's something makes sense. And then feasibility study is, we said that, I forget what analyzed current system is supposed to be, um, but it's logical. Um, I mean, it's logical that's part of a software development lifecycle. You want to look at your current system. Um, I forgot what I had in mind when I wrote this. This is a bunch of years ago. But feasibility study is, remember at the very beginning, we said that before you start, you want to see if it's feasible, right? And this Scrum is, of course, that is part of that is a software development lifecycle itself. Okay. Um, I mean, it's part of it, I should say. Um, the following is not a good software practice. Now, I didn't really stress this word with you, but basically, decoupled code means Okay, I'll leave it out. I should just say, did I talk about coupled code? Right. Okay, I'll leave that out. Okay. So using inheritance to handle different behaviors, we said was good or bad? Bad. Right strategy pattern is good. Using composition, I'm sorry. So the answer is one, right? That's bad. Strategy we said was good. Um, Three would be using composition, we said was better than inheritance, and using interface types for method parameters, right? We said that's good, right? In fact, that's the D of solid, right? If we use dependency inversion, says to be as generic as possible, an interface type is generic, right? It's not concrete type. Okay. Um, then a state pattern, a state diagram. Oh, not pattern. Shoot. Okay. Right. Remember what a state diagram does? What does it show?
The focuses on changes to a system's as object from a program execute.
It shows it shows that the different states, right? Right, an object or usually an object could be in, though some people make it about like the whole program could be. But basically, yeah, it's like, well, remember the example used was water. So water could be, let's say, four different states, three states, and then it transitions from one state to the other, right? So it could be the water state, and then from there it could go into the um, steam, or I forgot the other one, vapor. What?
Plasma water vapor.
Plasma water vapor. It sounds high tech. Sounds like Star Trek. A ray gun.
Biology degree.
Okay. Uh, So anyhow, so the answer would be changes to a object, right? It's really focusing on one object, though um, though some people get a little bit off track and they'll make a huge state diagram, which okay. Sequence of messages between objects and an object. No, that would be a sequence diagram. Uh, Represents the goal system users. No, that's requirements. Um, how the interaction, that's, um, I don't know what that would be. Uh, a system and other actors. I don't know what I had in mind, but it's not that. It's basically number one, okay? Um, and this is a requirement, I think. I forgot what I had in mind there. Okay, but I mean, for which one I forgot. Uh, how the interaction with which is designed to interface. Uh, I forgot what diagram does that. Uh, System, the actors, which is system. I probably meant um, the use case diagram, right? But yeah, that's it. That would be I should say activities. Be more clear. Okay, like I said, I got better at this. I hope. Okay. 11. The following is a non-functional requirement. Well, let's look at them. Scalability is the ability to what? Right, the ability to handle more load or right, or even less load, right? Page color is functional because it's very specific. A business rule is also specific. A report is also specific. And a search feature is, right, those are all functional requirements. Scalability is a general thing with the program that it could be able to handle more load. Um, uh, a missing functional requirement usually causes software to be unusable by the user. No, right? If you're missing one feature, if one requirement, you can still use it. But a non-functional requirement, will usually, kill the program, right? Because if it's too slow, then it's not usable. Sometimes, yeah. Um, in fact, just happened to me that we just had a new release and something that used to go fast started going slow. So when you type one, it would do a search, and then you type 1, 2, like we were entering a number, every time you entered a new digit, it would do a new search. And then for some reason it worked pretty quickly before, but now it was too slow. So I just actually today had to fix that. So um yeah, so that and that they were very upset about because it was really upsetting to them to have every time they typed a number, it would do a whole search, a slow search. Okay. Software performance is it functional? No, it's non-functional. Because performance is speed, it's a non-functional. Web page background color is a no, that's functional because it's very specific. Non-functional requirements are easy to test. No, they're harder to test, right? In fact, this is all from chapter 4, by the way, right? Where we said that um, they're harder to test because they're very like you have to come up with specific ways of testing like performance, right? You have to have like specific tests. Like if you want to know if a program is fast, you have to quantify it somehow, right? You have to say, well, it when I hit the save button, it gets saved in 1 second, right? Or if I do a search, it'll return results within 2 seconds, something like that. Okay, a lifeline, we just got through this. That's going to be a sequence diagram. Which design pattern is shown in the code below? Singleton, yeah, right? Because it's saying only return one, right? Um, and this is, yeah, okay. Um, okay, this is not really going to be on. I'm just get rid of that. Well, no, this is really a programming question. I think we might have had this. Right. So over here, type of diagram is this? It says, but right. But this is this example of a state diagram, right? It's go. It's transitioning. That's the word. It's transitioning from one state to another. This is a good state diagram because it's actually about one object, right? The door can either be open or closed. Apparently, it can't be halfway open, according to this diagram, right? Let's say it has a spring on it, right? And either you open it, like, and you put a thing underneath it so it stays open, or if you take it away, it's just gonna lock, right? Sort of like an emergency exit door, right? Or like the doors they have in the trains, right? That they always close, right? Right. So either it's open or it's closed. It's not in the middle. Um, Okay, so this would be a state diagram, right? In fact, it says so. So, okay. Uh, no, we're not going to have this on the final. I could tell you that. So, but what type of diagram is this called anyhow? Which? A class diagram, right? Right, because it's showing relationships between objects, right? But you don't have to know the multiplicity and all that. Just know that this is called a class diagram because one of the type of UML diagrams. Okay. Um, okay. You don't have to know this. Um, I'll just say the diagram above. A class diagram. And I'll just get rid of these questions. Um, okay. Match the terms on the left with the terms on the right. So waterfall process. Yeah, very good. Wow. Oh, you already looked at that, right? Oh, no? Well, that's fast. Incremental process, right? Software reuse, right? Very good. Did everybody hear the answers? Waterfall process is airplane flying software, right? So that would be 4. And then incremental allows many changes. It's really not many changes, but allows changes uh, easily or something. I don't know. Well, you get the idea. Software reuse is we're using open source software, and client server. Well, we only have one option. That would be email program, right? He knows it's 432 4321, right? Okay. Uh, what are the attributes of good software? Acceptability. By the way, I'm not going to ask so many questions from the first part of before the midterm. This happens to be in this test. But the one we're doing what I'm giving is gonna have more, it's weighted much more towards after the, the, um, the midterm. Okay? So concentrate on that. What are actually good software, acceptability, dependability and security, they're all good, right? Acceptability means that um, it's um, I would say it's easy to use, but that's usability. Whatever it is, but they're all good. Okay, so it's A, B, C, D. Okay, so efficiency, maintainability, dependability, and security. Do you remember the difference between security and safety?
Safety is the one you don't want to get harmed.
What?
Safety, you want to get harmed. Security is just like.
Data integrity.
Protecting, right? Security is protect, and safety is no one gets hurt. And what's in between authorization and no, sorry, it's authentication and authorization. I'll put that down also.
Nation is
Yeah, what a difference.
someone prove that they're allowed to do something.
That's which one?
Authorization.
Authorization.
What?
Authorization. Authentication is just making sure that's the real person you think it is.
The authentication verifies authentication just verifies your identity, right? Like that's when, like when you enter your password, verifies your identity. Because they sound the same and people use them, but they're really much different. And authorization, it checks if you have permission. Do you remember for authentication, which architecture is the best? Remember we said that? If you want to, for authentication, like usually what's used by most websites. Which, remember, we use a layer program, right? Use layers, and the outer layer is going to be the security layer, right? Just like Queens College, right? So the authentication to let you in to check who you are, and that would be, and then once you're in, authorization would decide what you could do, right? Authentication will make sure you're a member of, say Queens College when you log into CUNY First or CUNY, and then authorization will decide, well, if you're an instructor, you could do this. If you're a student, you could do that, right? By the way, do they require the students to take these mandatory courses? That like any mandatory like violence courses or what? They don't make you do it?
If you're a club leader, you have to take sexual harassment, some like thing online, but that's it.
Okay. I gotta take workplace violence and, which is really terrible because I have to do it at in my day job. So I have to watch the same thing twice. Uh, yeah, and I have to do it every single year, which is really, really annoying. Okay. Um, what are okay, so basically it's all of them. Oh yeah, we did that. Okay. So, um, okay. Again, it's not, this is not, I'm gonna take this out. I'm not gonna, we're not doing it on this final. Well, you should know it anyhow. What are the two things being shown here? Right, right, the dark diamond's composition, the light one is aggregation, but it's not gonna be on it. I just want to leave it there. So, um, so it shows that no, it doesn't show vehicle requires engine. It shows that engine require inherent for, no, it's aggregation, it's number 3, right? That would be the answer. Okay, but it's not gonna be on it. Depends the inversion principle. Again, it's um, it's basically 1 and 3. Yeah, yeah. That basically that we should use interfaces, right? And as opposed to specific classes and high-level modules should not depend on low-level modules, but really, that's the way he says it. Oh my gosh, already 10 o'clock? Okay. We're nearly done. Right. Oh. So should we finish up on Saturday night? Or, okay, so we'll finish up Saturday night. Okay. Thank you for your patience. We did a lot. Okay. But basically what I'm gonna do Saturday night is just go through all the folders. Yeah. Okay, good night.